Good afternoon, everyone. So, in the previous class, in the yesterday's class, we have discussed regarding semiconductors, and we have started another chapter that was electric charges and field. In electric charges and field, we have discussed regarding Coulomb's law. What was Coulomb's law? We know that whenever there are two charges which are separated by certain distance r, then the force of attraction or repulsion between two charges is directly proportional to product of the charges and inversely proportional to square of the distance between them. And further, what we did, we have derived the formula for Coulomb's law, that is Coulomb force. What was the formula for Coulomb force? F is equals to K into Q1 Q2 divided by R square. This was the force of attraction or repulsion between two charges which were separated by certain distance r. And what was the value of K? K was known as constant and its value was 1 by 4 pi epsilon naught, and its numerical value was 9 into 10 power 9. And what were the units? Newton meter square divided by Coulomb square. So this was the thing that we have discussed yesterday. Further, what we have discussed regarding Gauss law. I hope everyone remember the formula for Gauss law. What was the equation? Total electric flux. Flux phi is equals to closed integral E bar dot ds bar is equals to 1 by epsilon naught q net. So this was the Gauss law. And what is the statement that I have given for Gauss law? Total electric flux through any closed surface is equals to 1 by epsilon naught times the net charge enclosed. Further, we have discussed 4 important uses of this Gauss law. And in the next question, we have discussed regarding electric field intensity, which we are going to continue now also. So what was the definition for electric field intensity? Electric field intensity was defined as electric force acting per unit positive charge. And what was the unit for this electric field intensity? Newton per Coulomb. Further, we have derived one formula for electric field intensity due to point charge. Electric field intensity due to which charge? Point charge. What was the formula? We were getting the formula something like this: KQ divided by R square. So these were the things that we have discussed in yesterday's class in which chapter? Electric charges and field. Now let us continue our topic. So in today's class, we are going to discuss the remaining questions from electric charges and field. The next question is expression for electric field intensity due to electric field along the axial line of an electric dipole. Further, we will be discussing electric field intensity along the equatorial plane of an electric dipole. So before starting this, let us understand what is the meaning of electric dipole. So let us understand what is the meaning of electric dipole. See here, di represents 2. How many poles? There are 2 poles. Let me consider 2 charges. There is one charge plus Q, and I am having one more charge. I am having another charge minus Q here. Both are having same magnitude but opposite direction, and both of them are separated by a small distance 2a. This type of arrangement is called as electric dipole. So what is an electric dipole? 2 equal and opposite charges. 2 equal and opposite charges separated by a small distance. This type of arrangement is called as what? Electric dipole. And we'll be having one formula for electric dipole moment. It is given as length of the dipole into any one charge. I am taking here positive charge. So this is the formula for electric dipole moment. Remember this, we'll be using this formula while obtaining the expression for electric field intensity along axial line and electric field intensity along equatorial plane. I hope everyone might have understood the definition for electric dipole. So what is the definition for electric dipole? two equal and opposite charges separated by a small distance. Separated by a small distance. So this is the definition for electric dipole. If you are done with this, let us continue to our next important SAQ from this electric field and charges. So our next important topic is, I think this is the fourth question, fourth concept we are going to discuss in electric field and charges. What is that? Electric field intensity along axial line due to an electric dipole. Carefully listen this answer and note down the things. While deriving this equation or expression, you are supposed to draw the diagram. For drawing this diagram, you will be getting the marks. So first of all, let us consider an electric dipole. I am drawing the diagram somewhere here. Let us consider an electric dipole. What is the meaning of electric dipole? Two equal and opposite charges separated by a small distance. Let me consider the charge here is plus q and the charge here is minus q. And both of them are separated by a distance 2a. I am considering half distance as a and other half distance as a. And this is the center of electric dipole. This is the center of electric dipole. Now, what I am doing? Along the axis of this dipole, I am determining the electric field intensity. Let me consider one point P. Let this be a point P where I have placed a unit positive charge. Here I have placed a unit positive charge Q. This is unit positive charge. See here. Now carefully see the diagram. By looking at the diagram only, we are going to solve this answer. So there is an electric dipole which is having plus q charge and minus q charge separated by a distance how much? 2a. Now I have considered a point P which is at a distance of r, from the center of the dipole. This is at a distance of r from the center of the dipole. Now see here, what will be this distance? From plus q charge to point P, what is this distance? From plus q charge to point P, what will be this distance? If this distance from center se leke P tak ka distance r hai, from the center to the point P the distance is r, then what will be this distance? This distance will become r plus a. And what will be this distance? From minus q charge to point P, what will be this distance? This distance will become r minus a. I hope you are getting this. Let me consider this to be a point A and this to be point B. Now this is the entire arrangement for this particular answer. What I have did? I have considered an electric dipole. What is an electric dipole? Two equal and opposite charges separated by a small distance. How much distance? 2a distance. From center to point A, what is the distance? A. From center to point B, what is the distance? A. And from center to point P, what is the distance? R. So what will be this distance from point P to A? It will become R plus A. And what will be this distance from B to P? This will become R minus A. I hope you understood this diagram. Now everyone see this diagram carefully. Everyone see here. Now, here we are having negative charge. And at point P, which type of charge we have assumed? Here we have assumed a unit positive charge. So what will happen? Negative and positive charges will attract or repel each other. They will attract each other. So here, in this direction, there will be electric field. I am writing that is electric field due to B. Electric field due to B. Because at point P, what we have assumed? We have assumed a unit positive charge. Here there is a positive charge. Here there is a negative charge. Positive charge and negative charge try to attract each other. So here I am drawing the electric field in this direction, which is because of point B. Now let us consider this charge. At point A, we are having positive charge. At point P also, we are having positive charge. What will happen? Positive charge will attract or repel. They will repel. So the net electric field here acting in opposite direction to EB. So here the electric field is due to A. I hope you understood this. At point P, we have considered a unit positive charge. Here we are having negative charge at point B. What will happen? Positive and negative charges will attract each other. So that is the reason I have written the electric field in this direction. If I consider at point A, which type of charge is there? Positive charge is there. At point P, which charge is there? Positive charge is there. Positive charge attract or repel. They will repel each other. That is the reason I have written the direction of electric field opposite, away from that point A. I hope you understood this. Now everyone see here. Now we are going to derive the expression. So I can write electric field due to charge at point A can be written as, what is the formula? 1 by 4 pi epsilon naught Q divided by R square. So what is the distance from A to point P? What is the distance? It is R plus A. So this will become R plus A whole square. Okay. Next I am writing electric field intensity due to charge at point B. Which type of charge is there? Negative charge. And what is the distance from point B to point P? It is R minus A. So what will be the electric field intensity here? 1 by 4 pi epsilon naught Q divided by, what is the distance from B to P? It is R minus A whole square. R minus A whole square. I hope everyone understood till here. Now we are going to determine the net electric field due to this electric dipole. I can write net electric field E net is equals to EB minus EA. EB minus EA. Sir, why not EA minus EB? Why you are writing EB minus EA, sir? Means, see here. In case electric field is inversely proportional to distance. Here what is happening? Distance is increasing or decreasing? Here distance is decreasing. As the distance decreases, what will happen to electric field? Electric field will increase. Similarly, see here. Here distance is increasing. R plus A, something will give again higher value. So here distance is increasing. अगर यहाँ पर distance increase हो गया तो what will happen to electric field? Electric field will decrease. So we will be doing higher minus lower. So that is the reason I am writing EB minus EA. Let us substitute the values. What is the value of EB? Here 1 by 4 pi epsilon naught Q. Here 1 by 4 pi epsilon naught Q. I can take all these things common outside. So what this will become? Q divided by 4 pi epsilon naught. And what will be left with? Will be left with 1 by R minus A whole square minus 1 by R plus A whole square. I hope you are getting this. EB की value क्या है? What is the value of EB? 1 by 4 pi epsilon naught Q divided by R minus A whole square minus, what is the value of EA? 1 by 4 pi epsilon naught Q by R plus A whole square. So what is common in this? Q by 4 pi epsilon naught is common. That is the reason I have taken that outside. Now let us cross multiply this. If I cross multiply this, this will become Q divided by 4 pi epsilon naught. This R plus A whole square will come here. R plus A whole square minus, and R minus A whole square will come here. This will become R minus A whole square divided by A minus B whole square into A plus B whole square. What it will become? It will become R square minus A square whole square. Remember this. Many of the students will be making mistake here. You will be writing R square minus A square. If it is A plus B into A minus B, it will become A square minus B square. But what is it here? R minus A whole square into R plus A whole square. It will become R square minus A square whole square. Now let us simplify this. Directly you can write down the 4 steps in annual examination. But I am simplifying here. Let us see here what will happen. So here we are getting Q by 4 pi epsilon naught. Q by 4 pi epsilon naught. What is the formula for A plus B whole square? A square plus B square plus 2AB. So R plus A whole square will become what? R square plus A square plus 2RA. Again, minus is there. What is A minus B whole square? A minus B whole square will become A square plus B square minus 2AB. So this will become R square plus A square minus 2RA divided by, what is the value? R square minus A square whole square. I hope you are getting this. Now see here, if I multiply this negative sign here, this will become minus R square and plus A square will become minus A square, but minus into minus will become what? Plus. So all these terms will get cancelled. Finally, we'll be left with what? Q divided by 4 pi epsilon naught. What we are left with? 2RA minus into minus, it will become plus into 2RA. So this will become 4RA divided by R square minus A square into whole square. I hope you are getting this. You might have understood till here. Idhar tak samajh gaye na? So more 3 steps are there. After that, we are going to finish this answer. Let me move this diagram somewhere here. Okay, I hope you are seeing this, able to see this. Now see here. I'm continuing this answer here. See here. So this equation 4RA into Q. I'm going to write this equation in terms of what? Electric dipole moment. Electric dipole moment का formula क्या है? I know that P is equals to 2AQ is the formula for electric dipole moment. So final answer I am going to write in terms of electric dipole moment. How I can write here? P is equals to what? 2AQ. Here A is there. Here Q is there. Here 4 is also there. So I can write 4, 2 into 2. So what this equation will become? E net. E net is equals to 2 into 2QA into R. See here, 4RAQ. Here also 2 into 2 will become 4RAQ divided by, what is the value? 4 pi epsilon naught, 4 pi epsilon naught R square minus A square whole square. Understood till here? I hope you all are getting this. So finally, I am writing one condition here. What is that condition, sir? Means I know that what is the value of P? P is equals to 2QA. Further, I am considering one more condition. What is that condition? This value of R, this distance from center of the dipole to point P is very large when compared to distance A. So the above equation will become E net is equals to 2 into 2QA की जगह क्या लिखना है? We are supposed to write P into R divided by, as R is greater than A, I can neglect A. R is very much greater than A, so I can neglect A. R square into square क्या बन जाता? R power 4 बन जाता. So this will become 4 pi epsilon naught into R power 4. So here R and this power 4 will get cancelled. So our final answer for electric field intensity along axial line of an electric dipole will be 2P divided by 4 pi epsilon naught. Here 4 is get cancelled, 1 R and 4 is get cancelled. So we will be left with Q. So this is the end of this answer. Very important question. Many times they have asked in the examination for short answer type question. So what we have discussed, we are determining the electric field intensity of an electric dipole along axial line and along equatorial line. What was the definition for electric dipole? Just now we have seen the definition for electric dipole: two equal and opposite charges separated by a small distance. And the formula for electric dipole moment is P is equals to 2AQ. And the most important question that we have discussed is determining the electric field intensity along the axial line due to an electric dipole. So here we are having an electric dipole. Here we are having an electric dipole. From center to point A, I have taken the distance A, and from center to point B, I have taken the distance A. So the total length of electric dipole is how much? It is 2A. At one particular point P, I have considered a unit positive charge. The distance from center of the dipole to this point P is how much? It is R. And the distance from point A to point P is how much? R plus A. And the distance from point B to point P is how much? R minus A. Next, what we have did? We have determined the electric field acting due to this point charge minus Q and point charge plus Q at this particular charge, unit positive charge Q. And we have determined the net electric field intensity along the axial line due to an electric dipole. I hope you understood this answer. If you are done with this, we'll move on to the next answer, that is next important concept, that is electric field intensity along equatorial plane due to an electric dipole. So our fifth question, fifth important concept from this chapter is fifth one. Electric field intensity along equatorial plane due to an electric dipole, due to an electric dipole. Now, if you are able to understand the diagram or arrangement for this diagram, then you can easily write down the answer for this particular question. Very easy explanation, just you are supposed to concentrate on the diagram. So let us again consider an electric dipole. What is an electric dipole? Electric dipole is nothing but it is an arrangement which consists of two equal and opposite charges separated by a small distance. Let me assume a positive charge at this particular point plus Q, and there is one more negative charge at this point. I am writing this one as what? Minus Q. And the distance between electric dipole is how much? 2A. I am considering the center of an electric dipole. So this distance will become A. This distance will become A. Let me consider this point as O. Now I am considering a unit positive charge at this particular point P. What is here? Here there is a unit positive charge. Now everyone carefully see this diagram. If you are able to see this, understand this diagram, you can easily write the answer. Everyone see here. Now try to answer with me. Which type of charge is here? Positive charge. At point P also there is this type of charge, positive charge. Positive charge will attract or repel each other. They will repel each other. So here the net electric field acting will be, here the net electric field acting will be away. So here I am writing the net electric field is acting away. So this is due to which charge? Charge at position A. Let this position be A and let this position be B. So I can write this is electric field due to charge at position A. I hope you are getting this. Now see here. One more charge. Here we are having negative charge. Here we are having positive charge. Attraction force or repulsion force, attractive force will be there. So this charge will try to move towards point B, because they are opposite. So opposite charges attract each other. So here the net electric field will be, field direction will be somewhere here. So this is due to which charge? Here I can write this is due to electric field due to charge at point B. I hope you are getting this diagram. What I did, I have taken an electric dipole. I have divided this electric dipole into two parts. This is the center of the dipole. Here we are having positive charge. Here we are having negative charge. What charge we have assumed at point P? At point P, we have assumed a unit positive charge. So here at point A, there is positive charge. At point B, there is positive charge. Sorry, point P, there is positive charge. They will attract or repel. They will repel. That is the reason here the electric field is going away. So here we are having negative charge, and at point P we are having positive charge. That is the reason the net electric field is acting towards B. Now from point P to O, I am drawing one line. Let this height be R. Let this height be R. Now I hope everyone know Pythagoras theorem. If this adjacent side is A and this side is R, what will be this side? This side will become under root A square plus R square. Isn't it? This will become under root A square plus R square. Similarly, this side will also be getting what? Under root A square plus R square. Here angle is theta. Here also angle is theta. Now everyone carefully see here. If I ask you a question, I will try to explain this thing. Directly I can write down the answer, but let us understand this. See here, electric field is a vector quantity. So if I ask you a question, whether this electric field is along x-axis or y-axis, what you will be telling me? No, sir, it is neither along x-axis nor along y-axis. It is lying in xy plane. You will be telling that, sir, it is lying in xy plane. Whenever there is a vector which lies in xy plane, what you are supposed to do? You are supposed to resolve that vector into two components, horizontal component and vertical component. The components kya bante dekhiye, everyone see here. What will be this component? So here I am writing one component, and the other component will be some here. I am resolving this EA into two components because EA is lying in xy plane. Whenever there is a vector which lies in xy plane, what we are supposed to do? We are supposed to resolve that vector into two components. Now carefully see this. If this angle is theta, this angle will also become theta. So what will be this component? This component will become EA cos theta. I hope you are getting this. Concentrate. Thoda mathematics hai, little bit mathematics. Try to concentrate. You will understand this. See here. Now I have resolved this component. Theta raha component kya ban jata? It will become EA cos theta. And what will be this component? This will become EA sin theta. EA sin theta. I hope you are getting this. Similarly, see here, EB is also neither in x-axis nor along y-axis. Again, EB is also lying in xy plane. EB is also lying in which plane? XY plane. Again, what we are supposed to do? Again, we are supposed to resolve this component. Let us resolve that component. I am resolving this component. EB ka component. Here we will be getting one more component. I am writing this one as, and there is one more component which is acting downwards. Carefully understand this. Isko agar samajh gaya aap laga to answer you can write very easily. See here, initially I have resolved this EA component. I am going to resolve this EB component. If this angle is theta, this angle will also become what? Theta. So this component will become what? This will become EB cos theta. And what will be this component? If this is EB cos theta, this will become what? EB sin theta. Ye kya ban jata? EB sin theta. Now carefully see here. Now we are going to finish this diagram, explanation of this diagram. Once the explanation of diagram is finished, you can directly see the diagram and write down the answer. Carefully see here. See here. Let us determine the values of EA and EB, electric field due to charge at A and electric field due to charge at B. Let us determine those two values. I am writing electric field due to charge at A can be given as 1 by 4 pi epsilon naught Q divided by, what is the distance from A position to P position? It is under root A square plus R square. So this will become under root A square plus R square whole square. I hope you are getting this, whole square. Next, what is the electric field at position B? We can write 1 by 4 pi epsilon naught Q divided by what is the distance from position B to point P? Position B se point P ka distance kya hai? It is under root A square plus R square. Under root R square plus A square whole square. See here, if you carefully see this, electric field due to charge A, due to charge at point A, and electric field due to charge at point P, both the electric fields are same. I can write, here I am taking magnitude. I can write magnitude of electric field at point A is equals to magnitude of electric field at point B. I am equating it to some electric field E. What I am doing? I am equating it to some electric field E. Now see here, our answer is finished. Carefully see the diagram. See here. As EA and EB are same, see here. EA sin theta is acting in upward direction. EA sin theta is acting in upward direction, and EB sin theta is acting in downward direction. EA sin theta is acting in upward direction and EB sin theta is acting in downward direction. Both the electric fields are same. Yes. So this component of electric field this component of electric field and this component of electric field get cancelled. So what is the net electric field acting? Here we are having EA cos theta and here we are having EB cos theta. Both of them are acting in same direction or opposite direction? Both of them are acting in same direction. So I can write net electric field. I can write what? Net electric field E net is equals to EA cos theta plus EB cos theta. But what I know that EA is equals to EB is equals to E. So our EA net will become EA is equals to EB. So cos theta is there. So this will become 2E cos theta. I hope you are getting this. We are end of this answer. Only 3 steps are left. After that, this answer is finished. Everyone see here. So this is equals to 2 into, what is the formula for electric field? Either you can take EA or you can take EB, your wish, because EA is equals to what? EB. Both of them are equals to what? E. So I'm writing Q divided by 4 pi epsilon naught. What is there? Under root A square plus R square whole square into, what is next? Cos theta. What is the formula for cos theta? We know that cos theta is nothing but adjacent side by hypotenuse. What is adjacent side here? This is adjacent side. What is hypotenuse? This is hypotenuse. So this will become what? A divided by under root A square plus R square. Dekho khatam answer. This square and root get cancel. 2QA. Just now we have written what is the formula for 2QA? P is equals to what? Electric dipole moment is nothing but 2QA. So this will become 2QA divided by 4 pi epsilon naught. 4 pi epsilon naught. We are left with what? A square plus R square, because square and root got cancelled, and this A square plus R square can be written as what? This can be written as A square plus R square. Under root can be written as 1 by 2. I hope you are getting this. Under root can be written as 1 by 2. So what will be our final answer? We know that 2QA is nothing but P. So this will become P divided by 4 pi epsilon naught. Here power 1 is there. Here 1 by 2 is there. X power n into x power m. What it will become? X power n plus m. So this will become A square plus R square. 1 plus 1 by 2 will become 3 by 2. 3 divided by 2. I hope you are getting this. So our final step, what is our final step? I'm writing the final step here. If R is very much greater than A, then what this equation will become? This equation will become E net is equals to P divided by 4 pi epsilon naught. R is very much greater than A. So I can neglect A. So what this will become? This will become R square whole power 3 divided by 2. So this 2 and this 2 will get cancelled. So our final answer for the net electric field along equatorial plane is given as P divided by 4 pi epsilon naught into R cube. P divided by 4 pi epsilon naught into R cube. So this is our final answer for electric field intensity along equatorial plane due to an electric dipole. I hope you are getting this. So here we are finishing the concept of electric field intensity. So in electric field intensity, we have discussed that electric field intensity is nothing but electric force acting per unit positive charge. Then we have determined the electric field intensity due to point charge. In the today's class, what we have discussed regarding electric dipole, and we have determined the electric field intensity along the axial line due to what? Electric dipole. So what is the final answer we got here? We got the final answer as 2p by 4 pi epsilon naught R cube. Next, what we have written? We have determined the electric field intensity along equatorial plane due to an electric dipole. So what is the final answer we got here? We got the final answer as E equatorial is equals to P by 4 pi epsilon naught R cube. I hope you understood this. Now we are left with one single is another important small concept that is called as expression for torque or couple on an electric dipole whenever it is placed in uniform electric field. If we are doing this concept, we'll be done with electric charges and field. Let us move on to that concept. Those who want to copy, they can copy this. So let us discuss the last topic from electric charges and field. Last topic from electric charges and field. Sixth topic. What is that? Torque on an electric dipole placed in a uniform electric field. Placed in a uniform electric field. Uniform electric field. So this is the last topic of electric charges and field. So we know what is electric dipole. Electric dipole means two equal and opposite charges separated by a small distance. Now what we are going to do, we are going to place that electric dipole in uniform electric field. What is the meaning of uniform electric field? Here the electric field lines will be parallel to each other. So let me consider a uniform electric field. Let me draw here, somewhere here. This is our uniform electric field. In this uniform electric field, what I will be doing? I'll be placing an electric dipole. So this is our uniform electric field. In this direction, this is E bar. It is originating at one particular point and it is moving away. So here what I will be doing, I will be placing an electric dipole. Let me place one electric dipole somewhere here. Here I have placed an electric dipole. Here I am taking negative charge. Let me consider this point to be A. Here I am taking positive charge. Let me consider here this point to be B. Now, due to this electric field, what is the force acting on the charge? We know that. What we know? We know that. What we know? Electric field intensity is defined as E is equals to F divided by Q. So from here I can write F is equals to electric force, F is equals to Q into E. So if I ask you a question, what is that question? What is the force acting on this positive charge? Means what you will be doing? You will be doing force acting on positive charge is given as Q into E. Here which charge we are having? Here we are having positive charge. And if I ask you a question, what is the force acting on negative charge? What we will be writing? Force acting on negative charge is given as F is equals to, which type of charge is there? Negative charge, minus Q into E. Minus Q into E. I hope you are getting this. What we did? We have considered a uniform electric field. In that uniform electric field, what we did? We have placed an electric dipole. Now here I have considered the positive charge and here I have considered the negative charge. The force acting on this positive charge is how much? Plus QE. Plus QE. And what is the force acting on this negative charge? It is minus QE. So if I ask you a question, what is the net charge? What is the net charge acting on an electric dipole? So what it will become? Force due to positive charge plus force due to negative charge. So what is the value of force due to positive charge? It is plus QE. And what is the force due to negative charge? It is minus QE. So here the net force is 0. Remember this. So net force acting on electric dipole is what? Net force acting on electric dipole is how much? 0. Whenever the net force acting on an electric dipole is 0, जब भी नेट फोर्स इलेक्ट्रिक डाइपोल पे जीरो रहता, व्हाट इट विल डू, द इलेक्ट्रिक डाइपोल विल स्टार्ट टू ऑसिलेट. व्हाट इट विल डू, इट विल स्टार्ट टू ऑसिलेट. उसके अंदर टॉर्क डेवलप होता, रोटेशन डेवलप होता, रोटेशन में जो फोर्स एक्ट करता, दैट इज नोन एज व्हाट, टॉर्क. So we know that whenever the net force on an electric dipole is zero, what will be developed? Torque will be developed. What is the formula for torque? What is the formula for torque? So torque is given as force into perpendicular distance. So we can take any force. Here torque is a force into perpendicular distance. Either it can be plus QE or minus QE. Now we are supposed to determine the perpendicular distance. Now see here. Let me draw one perpendicular here. And here this dipole is making some angle theta. This dipole is making some angle theta with respect to electric field. Let this point be A, this point be B, this point be C. Now this is a right angle triangle. So from this I can write, what I can write? Sin theta. What is the value of sin theta? Sin theta is nothing but opposite by hypotenuse. What is this opposite side? Opposite side is BC divided. What is hypotenuse? Let the length of the dipole is how much? Length of the dipole is 2A. What is this hypotenuse? AB. So from this I can write, what I can write? I can write BC is equals to, what is the value of AB? AB की value है 2A. BC is equals to 2A sin theta. BC is equals to what? 2A sin theta. So what is this value? ये perpendicular distance की value क्या है? This is becoming 2A sin theta. Similarly, let's write down cos theta. Cos theta बोले तो क्या? Adjacent by hypotenuse. What is this adjacent? AC divided by AB. So what this will become? This will become AC is equals to, again, what is the value of AB? AB की value क्या है यहाँ पे? 2A. So this will become 2A cos theta. So adjacent side क्या बन जाता है? This will become 2A cos theta. If you are done with this, we are done with the answer. Only 3 steps are left out. See here, what we did, we have considered a uniform electric field. Uniform electric field है बोल के कैसा मालूम होता? This electric field lines are what? They are parallel to each other. In that uniform electric field, what we did, we have placed an electric dipole. Whenever I am placing an electric dipole in uniform electric field, there will be one force which is acting in the direction of electric field on positive charge. What is that force? It is plus QE. There is another force which is acting on negative charge, and what is that charge? It is minus QE. Both of them are acting in opposite direction. So what is the net force acting here? Net force acting on an electric dipole placed in uniform electric field is what? 0. Whenever the net force acting on an electric dipole in uniform electric field is 0, what will be developed? The electric dipole will start to oscillate. So torque will be developed. What is the formula for torque? Torque is defined as force into perpendicular distance. So you can take any one force. Let us start the answer. So torque tau is equals to, I am taking force as plus QE. If you want, you can take minus QE also. I am taking the force as plus QE. QE into, which one is the perpendicular distance? 2A cos theta is the perpendicular distance, or 2A sin theta is perpendicular distance. This is perpendicular distance. ये electric field ये direction में, this is perpendicular distance. So I can write 2A sin theta. So what this will become? This will become torque tau is equals to, see here, again I am getting one formula, 2A Q E sin theta. ये फॉर्मूला किसका है? 2AQ फॉर्मूला किसका है? This is the formula for electric dipole moment. So I can write tau is equals to PE sin theta. Tau is equals to PE sin theta. So this is the formula for torque acting on an electric dipole placed in uniform electric field. If I want to write the same thing in vector form, what this will become? This will become torque tau is equals to, see, electric dipole moment is also a vector. Electric field is also a vector. Electric dipole moment का direction किधर से किधर रहता? It will be from negative to positive. Electric dipole moment का direction किधर से किधर तक रहता? From negative to positive. So this will become tau bar is equals to P bar cross E bar. P bar cross E bar. So this is the end of our answer final SAQ from electric charges and field. So in total, we have six important concepts from electric charges and field. First was Coulomb's law. Next, we have discussed Gauss law. Then we have started the concept of electric field intensity, and we have determined the electric field intensity for point charge along axial line, along equatorial line due to an electric dipole. Finally, we are done with this answer. Whenever what is the final thing? We are determining the torque produced on electric dipole due to an uniform electric field. And what is the final answer we got? We got the final answer as what? Tau is equals to P bar dot Q bar. Tau is equals to P bar dot Q bar. I hope you understood this answer. So let me check the time. If time is there, we'll move on to the next chapter. Yeah. We'll start electric potential and capacitance. Most probably tomorrow we are going to finish electric potential and capacitance. After that, we'll discuss another SAQ. I hope everyone understood the SAQs from this chapter. Let us move on to the next chapter. Next chapter. What is the next chapter? Electric potential and capacitance. Electric potential and capacitance. Electric potential and capacitance. So what are the concepts or what are the questions that we are going to discuss here? I will start with capacitance. First of all, we will be determining the equivalent capacitance for parallel combination, equivalent capacitance for series combination. Then we'll be obtaining an expression for capacitance of parallel plate capacitor. Once we are done with capacitance concept, we'll move on to what? We'll move on to electric potential concept. In that electric potential and electric potential concept, we are having one important question. Define electric potential, obtain an expression for electric potential due to a point charge. After that, we'll be discussing about electric field energy. So there are around 4 to 5 SAQs in this chapter. And further, there are two numericals. One numerical will be, he will be giving a capacitor of capacitance 9 microfarad. He'll be telling there are 3 capacitors, each of 9 microfarad, and he'll be asking you to determine the equivalent capacitance. Sometimes he'll be giving 3 different capacitors, and he'll be asking you to determine equivalent capacitance in series combination and in parallel combination. After that, he'll be giving some voltage, and he'll be asking you to determine the charge flowing through each capacitor. Okay. So we'll start with capacitance topic. First of all, we'll discuss capacitors connected in series. So what is our first concept? Series combination. Series combination of capacitors. Series combination of capacitors. See here. First of all, you are supposed to write down the definition for series combination of capacitor. What is the formula for capacitor actually? We know that capacitance is defined as what? Capacitance C is equals to charge divided by potential. This is the formula for capacitance. C is equals to what? Q divided by V. So see here, what is the meaning of series combination? Let me consider 3 capacitors. Let me consider 3 capacitors. This is capacitor 1. This is capacitor 2. And this is capacitor 3. This type of arrangement is called as series combination. See here, this is the first plate of capacitor. This is the second plate of capacitor. This is the first plate of second capacitor. This is the second plate of second capacitor. This is the first plate of third capacitor, and this is the second plate of third capacitor. You are not supposed to write this 1 to 1 to numbers in the examination. Just for explaining you, I am telling this. So how you are supposed to write the definition for series combination of capacitor? Carefully see here. The second plate of first capacitor, the second plate of first capacitor is connected to first plate of second capacitor. I hope you are getting this. The second plate of first capacitor is connected to first plate of second capacitor. Similarly, and second plate of second capacitor is connected to first plate of third capacitor. Similarly, next what will happen? Second plate of third capacitor will be connected to first plate of fourth capacitor. This type of arrangement is called as series arrangement or series combination of capacitor. How to define the series combination of capacitor? Second plate of first capacitor is connected to first plate of second capacitor. Second plate of second capacitor is connected to first plate of third capacitor, and so on. This type of combination is called as what? Series combination. You are not supposed to write down this 1 to 1 to 1 in the examination paper. Just for explaining the definition, I have written this. So see here. Now what I am doing, this is the capacitor of capacitance C1. This is the capacitor of capacitance C2. And this is the capacitor of capacitance C3. What I am doing? And applying a battery here of potential V. So here I am having positive potential. Here I am having negative potential. So what will happen? The charge will flow. The charge will flow through this capacitor. As the capacitors are connected in series, same charge will be flowing through all these capacitors. Same amount of charge will be flowing through what? All these capacitors. See here. So here same amount of charge will be flowing through C1, same amount of charge will be flowing through C2, and same amount of charge will be flowing to C3. Here the potential across C1 is V1. The potential across C1 is how much? V1. Potential across C2 is how much? V2. जाहिर सी बात है, if I consider हमारे फैन में, ट्यूबलाइट में हर एक जगह अलग अलग वोल्टेज रहता ना, इसके पास अलग करंट जाता रहता, फैन में से थोड़ा अलग करंट जाता रहता, तो यार पोटेंशियल डिवाइड हो जाता. Potential across capacitor C3 I am taking is V3. So what is the total potential? I can write total potential V is equals to what? V1 plus V2 plus V3. But I know that what is the formula for capacitance? I know the formula for capacitance as C is equals to kya? Q divided by V. So from here I can write V is equals to Q divided by C. लिख सकते हैं ना? C is equals to Q by B. V को यहाँ पर ले लेंगे तो C नीचे आ जाता. So V is equals to Q by C. Same charge flow होता, different charge flow होता, same charge flow होता, same amount of charge is flowing through capacitors in which type of combination? Series combination. So what this will become? Q divided by C is equals to what is the charge flowing through C1? The charge flowing through C1 will be Q only, divided by what will be the capacitor? What is the capacitor here? Capacitor is C1 plus what is the charge flowing through capacitor C2? Q only. And what is the capacitance? C2. Similarly, at point V3, what I can write? Q divided by C3. So I can take Q common here. Q common लिया तो क्या बन जाता? 1 by C is equals to Q of 1 by C1 plus 1 by C2 plus 1 by C3. This Q and this Q will get cancelled. Finally, I can write down the final answer for equivalent capacitance. 1 by C equivalent is equals to 1 by C1 plus 1 by C2 plus 1 by C3. So this is the final answer for equivalent combination of capacitors connected in series. So let us finish today's class here itself. Tomorrow let us discuss the equivalent combination of capacitors when they are connected parallelly. So what are the concepts that we have discussed today? We have discussed regarding, we have finished the chapter of electric field and charges. Today we have discussed the electric field intensity along axial and equatorial plane. Next we have discussed the concept of torque acting on electric dipole whenever it is placed in uniform electric field. And we have started a new chapter, that is electric potential and capacitance. In electric potential and capacitance, which concept I have started first? I have started the concept of capacitor. What is the formula for capacitance? C is equals to Q by V. What is the unit of Q? Coulomb is the unit. And what is the unit of volt? Sorry, potential? It is volt. So this will become C by V. C is Coulomb and V is volts. Here V represents potential. So finally, we have obtained an expression for equivalent capacitance whenever capacitors are connected in series. I hope you understood today's class. Please practice and revise this answer regularly so you can easily get through that examination. By the concept that we have finished till today, you can easily clear the examination and get more than 30 or 50% marks. We are left with only 3 or 4 more concepts. But after that, we'll be starting VSAQs. Once we are done with VSAQs, again, I will be discussing the left out important questions from waves and other chapters. Okay. So we'll meet tomorrow. Thank you.